Dear students, today we will learn about bits. Bits is a short version of binary digits. So this is the smallest possible unit in which we store data. And all information in computer is coded as a pattern of 0 or 1. And short form of binary digits is bits. One bit can contain only one value, either it will be 0 or 1. And they can represent text, audio, video, images, all kind of data can be represented using bit patterns. We will represent in this lecture some of the things. And the motivation to use bits or binary numbers to represent data is as follows. As it contains two values, 0 or 1, and 0 means false, 1 means true. So in chip, electric charge is also considered as false or true, whether there is a charge, whether there is not charge. So if there is a charge, that is translated to false, and in other words towards 0. And similarly, if there is a charge, that is considered or mapped to 1, which is converted to true. And these are the different units of bits. So 8 bits combine together to form 1 byte. And when 1024 bytes are combined, they form 1 kilobyte. And 1024 kilobytes are mapped towards 1 megabyte. And 1024 megabytes form 1 gigabyte. And 1024 gigabytes map towards 1 terabyte. So you must have heard about this kind of sizes of hard drives and RAMs. So for example, if you say that you have a hard drive of 1 terabyte, so this means it has 1024 gigabytes. If we want to find how many megabytes it has, you will again multiply it 1024. So it will become megabytes, and then 1024 will become kilobytes, and then 1024 will become bytes. So if you multiply all of these numbers, so then you will achieve number of bytes in your hard drive which can be saved. So if we have only 1 bit, so as I mentioned, that on 1 bit we can represent either 0 or 1. So in 1 bit we can only represent this thing. However, if we have 2 bits, so then we can represent 00, 01, 10, 11. So these are all of the possible combinations. So on both of the inputs it may have zeros. On first 0 and the second may have 1, then first 1, second has 0, and both have 1. So these are the all possible combinations which can be formed when we have 2 bits. So these become 4. And if we have 3 bits, then it will become 00, 00, 01, 10, 11. You need to write it again and put 0 to first 4 and put 1 to the last 4. So these are all combinations which can be made when we have 3 bits. And now if we conclude all of this, then we can see that if we have 1 bit, so it can form 2 patterns. So 2 bits can form 4 patterns, 3 bits can form 8 patterns, 4 to 16, 5 to 32, 6 to 64. So normally it will become 2 raised to power n, where n is the number of bits. So for example, if we have 1 bit, so 2 raised to power 1, which is 2 patterns. If we have 2 bits, then it will become 2 raised to power 2, which will become 4 patterns. If we have 3 bits, so 2 raised to power 3, it will become 8 patterns. So this means with 8 bits or 1 byte, we can store 256 different kind of patterns, and each pattern can represent one particular thing. So for example, if we want to store some text like A, B, or small a, or some other symbol like space, so there is a ASCII table which is available in your book, and which says that for A you need to store 65. How to store 65 we will learn in the next slide, because we need to convert this 65 towards binary number. So let's do it. So we have 65. So divide it with 2 because it's a binary division. 2 3s are 6, 2 2s are 4. So we remain with 1. Then 16, 0, 8, 0, 4, 0, 2 2s are 4, 0, and 2 1s are 2, 0. And then you need to write from bottom to top. So 65 binary would become 1 0 0 0 0. So then we have 1 2 3 4 5 zeros, and then 1. So this will become binary of 65. So if we want to store A in the drive, then we need to write 1 0 0 0 0 0 1. And there is a short form to represent this, which I want to explain you. So you can see that it is 65, and I have written a table which is a power of 2. So power of 2 raised to power 1 is 2, 2 raised to power 2, 2 raised to power 3, 2 raised to power 4, and so on. So you can see that we want to make 65. So if we on this bit and this bit, so 64 plus 1 will become 65, and others would remain 0. This one should be 1. So we wanted to make 65. We turned on the bits which were representing 65. Similarly, I can explain another example. For example, you want to display 32. So you need to turn 32's cell as 1 and put zeros in other cells. So this will represent 32. So if we summarize today's lecture, that we have learned basics of bits and bytes, binary representation, their units, patterns, how to convert decimal to binary, and we have performed different examples. And with this, I conclude today's lecture.